first project is to build a simple LiveView for changing the brightness of a light, and it'll live at /light.
Yep, it starts off with a brightness of 10%, and we can turn it off, turn it on, whoop, and we can adjust the brightness back down a little bit in increments of 10, or back up again.
It's basically a glorified counter, but it's a great way to step into the light of LiveView, so to speak. So let's go build this.
We've opened the LiveView Studio directory, which contains this Phoenix app. And let's start by defining the route for the LiveView we'll create. And we do that in the router. That's under lib, LiveView Studio Web, router.ex. And we're looking for this scope right here, which pipes requests through the standard browser pipeline. And there's a typical route to the Phoenix homepage. And then we added routes for these other LiveViews that we'll come back to later.
At this point, we just want to add a new live route for our light project.
To do that, we use the live macro and give it the path to match, which is /light. And then give it the LiveView module, which in this case will be light live. So request for /light will get routed to this light live module. Save the router, and then we'll go define that module. And by convention, LiveView modules live in the LiveView Studio Web live subdirectory.
And we see these other LiveView module files in here, and we'll ignore those for now.
We'll create a new file named light_live.ex. And then define our LiveView module. And because I'm using the Elixir LS extension in VS Code, if I type def mod and hit tab, well, it figures out the module name based on the file name. So it's LiveView Studio Web Light Live. And it's just a regular Elixir module. And to pull in all the stuff to make this a LiveView module, it needs to use LiveView Studio Web, the LiveView behavior.
And a LiveView module typically has three primary callback functions: mount, render, and handle event. So let's start with the mount callback, since it's the first callback that's invoked. It's automatically called when the request comes in through the router, and it's here that we assign the initial state of the LiveView process.
And mount takes three arguments. The first one is params. It's a map containing the query parameters, as well as any router parameters. And we don't need those for this LiveView, so we'll ignore them. And then the second argument is session, and it's a map containing session data, and we don't need that for this LiveView, so we'll ignore it as well. Finally, the third argument is the LiveView's socket. It's a struct, and we do need this one because the socket is where all the LiveView processes state is stored. And to assign state to the socket, we use the assign function, and it takes the socket as the first argument, and then any key value pairs to assign to that socket.
Well, let's say we want the light to initially be set to a warm glow of 10% brightness.
Sure, so the key will be brightness, and the value will be 10. And the assign function returns a new socket struct that has the brightness assigned, so let's go ahead and assign that. Socket equals the result of calling assign, which is a socket.
Now don't worry, we'll look at this socket struct in more detail later.
And then mount must return a tuple with two elements, the atom OK, and then the socket. Now you'll often see this inlined. If we were to take this, we could inline it for that. And because assign returns a socket, well, this will work just as well. But we'll go back to the two-line version for now, and you'll see why in a minute.
Okay, so now we need to render the LiveView's current state, and we do that by defining a render function.
And render takes a single argument, assigns, which is a map containing the key value pairs we assigned to the socket in mount. And render needs to return a template that renders HTML content, and we create that template using the special hsigil.
Hello, template.
And start it with triple double quotes, and it also ends with triple double quotes.
And this ~h creates what's called an HEEX, or HEEX template, which is static HTML plus embedded Elixir, or EEX, tags. So let's start with some static HTML. Let's have an H1 with the heading Front Porch Light, and then a div with an ID of light. And inside that div, we'll have another div with a class of meter. And then inside of that, we'll have a span. And the app already includes CSS to style this up for us. So in this span, we want to render the brightness value that's currently assigned to the socket.
Right, and it's in this assigns map that's passed to render. And we can interpolate the brightness value using an EEX tag like this. Less than percent equal assigns dot brightness to get that value, and then percent greater than, and then we want a percent on the end of this since we want to represent this as a percent. Or since we're in a template, we can also access assigned values simply using an @ sign. So we can remove assigns dot, and it's just @ brightness. So now in the browser, if we go to /light, we see our light has an initial value of 10%. So when our app receives an HTTP request matching this path /light, the mount function in the Light Live module is invoked. It assigns the LiveView's initial state, a brightness of 10 in this case, to the socket. Then render is called to render HTML, and we can interpolate values assigned to the socket. And one cool thing about the Heeks templating engine is that it validates the structure of templates.
Yeah, like what if we forget the last div?
Well, we get this compile time error in the browser. End of template reached without a closing tag for div. I love this. It's super helpful.
Now, if you're wondering, we could put this Heeks template in a separate template file rather than directly in the render function.
But unless it's a really unruly template, I prefer keeping the template right here in render where it's easy to reconcile with the code. And I have a pretty high tolerance for templates in my LiveView modules because the alternative is jumping between two files.
Blah. Now later in this course, we'll see how to make separate template files along with some other important benefits of Heeks templates. Now we said this socket here is just a struct, so what does that struct look like exactly?
Well, let's take a closer look by inspecting it, and we'll do that after we've assigned the initial brightness. io.inspect socket. Save that, and now if we hop back into the browser, it auto-reloads and mount gets invoked. So now if we take a peek at the server log, we see this Phoenix LiveView socket struct, and it has an assigns field whose value is a map containing all the LiveView's state. So in this case, the map has a brightness key with a value of 10, and a couple other pieces of state that LiveView assigns by default. And notice in this changed map, it flags the brightness value as having been changed. So calling the assign function as we did in mount simply adds key value pairs to the assigns map in this socket struct. Then when render is invoked, it's passed the socket's assigns map so the template can access the LiveView's current state. Okay, so let's remove this io.inspect.
So let's take the next step. If the brightness is 10%, we want 10% of this light meter to light up yellow. To do that, we need to style this span so it has a width equal to the brightness value.
Sure, we'll just add a style attribute with a width. And we need to interpolate the value of brightness right here. And you might think we could just use the same EEX tag as below, less than percent equals @ brightness. Like that. Oh, and we want this to be a percent, so we'll tack on a percent sign at the end. But inside an HTML tag like this, we can't use EEX tags, because remember, Heeks templates are validated, and this isn't valid HTML. Instead, within HTML tags like this, we need to put this whole thing in curly braces. So a curly here, and a curly there. And then rather than using these EEX tags here and here, and by using these curlies, this is an Elixir expression. It's a string, and we want to interpolate the value of brightness into that string. So it's just pound, another curly there, and one there. So this whole thing is an Elixir expression, evaluates to a string, with this value right here interpolated into that string.
So the rule is EEX tags can only be used in the body of an HTML tag. Inside the tag itself, curlies must be used. And now our light meter lights up. Nice. So now let's make this more interactive by adding two buttons, one to turn the light on and one to turn it off.
Sure, we'll put those underneath this meter div right here. We'll have a button, and it'll have an image, and this one's going to be images, light, off.svg. We've got some SVG files in the priv static images directory if you want to have a look at those. And then we'll just copy this button, and this one's going to have the light on SVG. Save it, browser reloads, and we've got our two buttons.
Now, when one of these buttons is clicked, we need to update the state of our LiveView process, and we do that by sending it an event.
So starting with the off button here, we add a special HTML attribute, phxClick, and its value is the name of the event to send. And because we're just wildly creative, the event will be off. And LiveView refers to this phxClick attribute and other attributes like it that we'll see a bit later as a binding. It binds a click event to the button, so when it's clicked, an off event will be sent via the WebSocket connection to the LiveView process. And similarly, the on button should send an event to update the state, so we'll just add a phxClick to it, and the event will be, oh, I don't know, how about on?
And then to handle those inbound events, we need to define handle event callbacks.
And we'll do that down here beneath render. Give ourselves plenty of space. Handle event. And it takes 3 arguments. The first is the name of the event. We want to handle the on event with this one, so we'll pattern match it. The second is any event-related payload, which we don't have for this one, so we're just going to ignore that second argument. And then the third argument is the socket, which, remember, has the current state of the LiveView process assigned to it.
Okay, then what should happen? Well, we want to set the brightness value to 100.
Right, so we just use the assign function again, this time to assign to the socket a brightness of 100. And it returns a new socket, so we'll assign it to the variable socket. And then handle event needs to return a tuple with the atom no reply and the updated socket.
And whenever a LiveView state changes, the render function is automatically invoked with the newly updated state. So now over in the browser, if we turn the light on, it goes all the way up to 100.
Cool, so now to handle the off event, we'll just copy this handle event right here. We'll pattern match the name of the event, which is off, and assign a brightness of 0. Save it. Browser reloads. We can turn it on and turn it off again.
And we've got some CSS animations behind the scenes that make this all nice and smooth. So now that we've got the hang of this, let's add a couple more buttons to incrementally dim the lights up and down, and we'll learn something new along the way.
We'll start by copying this off button here and paste it between on and off. And we'll have this one send a down event. And we've got a down.svg. And then we'll copy that button, paste it below. And it'll send an up event. And we've got an up SVG. And then we need to handle these 2 inbound events. So down here, we're just going to copy the on event, change the name to up.
And in this case, we want to bump the brightness up by 10 each time the button is clicked. So to do that, we need to access the current brightness value.
We can access that using socket.assigns, which returns the assigns map. And from there, we can get access to the value of the brightness key, brightness. Then we just bump up the value by 10. Then we just need to assign the new value to the socket so that the LiveView re-renders. So instead of 100, this will be brightness. And doing it this way will work, but there's a shortcut. When updating a value, we can use the update function rather than the assign function. An update takes the socket and then the key, which in this case is going to be the brightness. So we'll pass it the atom brightness. And then update takes a third argument, which is a function. And we'll pass it an anonymous function using Elixir's shorthand capture syntax. And this function receives the current key's value, in this case, the brightness value. So that's &1, which represents the first argument to the function. And then we just need to return the updated value. So we'll bump that value by 10, plus 10. So this updates the brightness value in the socket by running this function. It's an anonymous function that takes the current value of brightness, bumps it by 10, and returns that new value. And by updating that value in the socket, a re-render is triggered. So now if we hit this up arrow, we're going up 20, 30, 40.
Then we need an event handler to dim the lights. And let's just copy the up handler.
Sure thing.
We'll change the event to down. And then it just needs to knock 10 off the current brightness value. So now we should be able to crank up the brightness. There we go. And dial it back down a little bit. Perfect.
So stepping back and looking at what we've done, Mount initializes the state of the LiveView process by assigning values to the socket. Render returns a Heeks template, which renders the LiveView's current state. And we have handle event callbacks for each inbound event. They change the state of the LiveView using either assign or update. And whenever the state changes, render is automatically called with the new assigns to re-render the LiveView.
So it's a pretty simple programming model, and we're just writing Elixir code. But there's more going on behind the scenes than meets the eye. And next up, we'll look at the life cycle of a LiveView in more detail.